Hi everyone, good morning. I hope you are able to hear me. Can anyone please confirm?
Yes, sir.
Yeah, thank you very much. Yeah. So this is Bhaskar. I have 14 plus years of IT experience. Can you please make it mute? Yes. Yeah, this is Bhaskar. I have 14 plus years of IT experience. I started my career with Microsoft full stack, that is BI full stack, which is SSIS. I started my career with SSIS as a ETL developer. And later I worked for SSRS and SSAS in order to create the models and all. And later I got an opportunity to work for Microsoft. I was there for more 8 years. I was there with the different technologies that I adopted. Like I worked for Azure Data Factory and Azure Databricks and Power BI when I was there with Microsoft. And currently I'm working for one of Indian based company from Hyderabad. So currently I'm working as a senior data engineer. This is briefly about me. And before starting about a data engineer, what we are going to do with the Azure data engineer. So when you see this term, Azure data engineering, we are going to deal with the data. As a data engineer, the primary responsibility of the Azure data engineer is to deal with the data. So that means we are going to take the data from somewhere, we are going to do processing, we are going to give it to the downstream systems. So who are all the downstream systems? I'll give a brief idea about it. So at this point of time, I just wanted to say we are going to handle with the data. So what is this data? Data is a raw facts. So that means there will be numbers and there will be text. There will be dates and times. And even images also comes into the data. Audios, videos, all those comes under the data. So whenever the person is going to run the business, or if you take any business in the market, we're all going to get this kind of data. We're going to have a numbers in the business. We're going to have a text in the business. How this data is getting generated for your data processing. Your role is to process the data. Your role is to process the data and give it to the downstream systems for their business analysis. So in order to give that, you need to understand how we can get the data or how data is getting generated in general. So this data processing is not a new technology or new term. This was there for a long ago, but 2 decades ago, the data processing was started. So before Azure data engineering or before next generation services, what was the approach to process the data? How data was used to generate? So if you take this one, if you take a here, I mean to say, I'm having a business system here. How exactly the traditional systems used to process the data? If you take any business, if you take Amazon, we're all aware of how to order a product from Amazon. We're all aware of how we can make a transactions in the banking. Whatever the business it is, for them, they're going to have a business application. They're going to have a business application. That application is responsible to get the data from the customers. So just imagine I'm the customer for one of the business, you're the customer for one of the business, and someone else is a customers for the businesses. So if I take an example of Amazon, they're getting the transaction data, day-to-day transactions data from the business. And they're going to store the data in the systems. So traditionally, even now also, we are going to store our regular data activities in the OLTP system. This OLTP system is specifically designed for storing the data. Your transactional data is going to be stored. So day-to-day transactions we are going to have here. Day-to-day transactions are going to keep in this place. Once you have collected all this data as a company, what you're going to do with this data? The data is going to be there in the form of rows and columns, or the data is going to be there in the form of semi-structure. This is a structure. I have a column 1, column 2, and column 3. This kind of data, we can call it as a structured data. So previously in the traditional systems, or in the very long ago, decade ago, we used to have only structured data. We don't have other kind of data. So this structured data, how we used to process it? Every day I'm getting a transactions. I wanted to understand what is happening in my business to take the business decisions. As a business user, you consulted some persons, the persons who are providing a services like a TCS or whatever the service-based company, Infosys. They connected or they consulted with some companies to get the solution on top of their business data. So what they did is, in order to transform the data, as the data is there in the system is completely raw data. This is not ready for analysis. This data is not for analysis. This data is not ready for analysis. So in order to visualize the data with reporting, this is not the best practice to visualize directly from here to here. That is not the best practice. So what you have to do is you have to transform the data. You have to transform and give it to the cleaned data to the reporting systems. So reporting system is the downstream system for you. From your system, the reporting team is going to take the data for reporting analysis. End of the day, business users can understand only visualizations. You have a data in the form of rows and columns. You have a data in the form of rows and columns. But user can understand only in the form of charts. Who is going to build these charts is out of the boundary for us. As a data engineer, our part is this part only. Our part is this particular part. This is responsible by data engineers. So we need to collect the data from the various systems, whatever the systems they're having. I'm just giving OLTP system, but basically we are going to have a varieties of the platforms to bring the data. So in the traditionally, we have used, I told you, I started my career with SSIS, SQL Server Integration Services. It's a ETL tool, data stage, Informatica. By using all those tools or any one of them, we used to extract the data. The process of taking data from any kind of system, we can call it as a extraction. Without writing a code, with user interface, we started bringing data from here. And then we applied the transformations. Applied the transformations as per the business requirement. So what is a transformation? We'll talk about it. And then once the transformations are applied, loaded the data into the WLAP systems. These WLAP systems are specifically designed for analysis. The systems are specifically designed for analysis. Or we can also call them as a data warehouses. So why data warehouses are much more suitable for analysis is because we are going to have a historical data here. Historical data, we are going to have it, and we are going to have a cleansed data, and we are going to have a aggregated data. So varieties of options we are going to have in this particular system. This system is designed for only analysis. From this particular system only, this reporting team will collect the data from here. So as a ETL developers, they are responsible to bring the data from the varieties of the systems and integrate in a single system called data warehouse. So the data warehouse is going to have a historical data. This was a traditional approach. This was a traditional approach. And later what happened is, suddenly the data gets increased like anything. a decade ago, data started increasing exponentially. So that means these systems are not capable enough to have a massive volume of data. When I'm having massive volume of data, these systems, that means whatever the systems are there here, these systems are not capable enough to store the data. They're not able to store it. So when they're not able to store, definitely even it's not going to possible to process. So processing is also is a problem with these systems. So these two major problems occurred a decade ago. Then in order to provide the solution for this, in order to provide the solution for your data storage, in order to provide the solution for your data processing, the market adopted Hadoop. Most of you may be aware of Hadoop. What Hadoop is going to do. You may not know about what it is doing exactly, but the purpose of this Hadoop is to provide the solution for your big data. So when there is a massive volume of data, that we can call it as a big data. So Hadoop was introduced to the market to provide the solution for your big data. And these systems are capable enough to process only structured data. And by the point of time, by the point of Hadoop, there was three varieties of the data. We have a structured data, semi-structured data, and unstructured data. So these systems were not capable enough to process all varieties of the data. That is also is one of the big problem. Why we are coming out of this traditional approach a decade ago is started transition to move towards from the traditional systems to a new generation that point of time, decade ago, that is Hadoop. So Hadoop is a distributed file system, or we have a framework where we can distribute the data and we can process it. These two problems were there, I just said. One is data storage, another is data processing. To provide the solution for these two problems, or when you have these two problems, we can say that is a big data. Now, question is, how can we provide the solution for your big data? How can you provide a solution for your big data? A big data means the data that cannot be stored. I have a system. My system storage is, just imagine 500 TB, 500 GB. My laptop storage capacity is 500 GB. If I'm having more than 500 GB, that is, just imagine 501 GB, then my laptop is not capable enough to store the data. I cannot store it because I can store only up to 500 GB. Now, in my laptop point of view, I can say this is a big data. I can say it is a big data. And I have a Gmail. Most of you are aware of it. Gmail. How much size you can attach? You can attach up to maximum to 50 MB. If you have a more than, sorry, not 50, it's 25 MB. You cannot go for more than 25 MB. So that means in this particular point of view, in the Gmail point of view, this 25 is fine. But if you have a 26 MB file to attach, then this we can say it is a big data, because your system is not capable enough to store the data and to process the data. So that is what I'm saying. The data that cannot be stored in your system, if you're not able to store the data in your system, that data we can call it as a big data. Or the data that cannot be processed with your system. I have a SSIS, but I'm not able to process my data which is there in the systems, in the source. So if you're not in a position to process with your system, that data we can treat as a big data. It's a basic definition that I'm giving. And the characteristics of big data is three ways. So I don't want to go more in detail about it. How do volume, varieties, and velocity. So volume is massive volume of data that you can store here. In my current project, we are handling 1.2 TB data we are having in the target systems. My source may be more than that, but I'm having the system that their report users are connecting, that particular systems are having, that particular storage is having 1.2 TB. It's all depends on the requirement you're going to have it. So when you have a massive volume of data, then that will be treated as a big data. And varieties of the data we are going to have: structured data, semi-structured data, and unstructured data. So structure means you're going to have a rows and columns. If you take a table, you're going to have a columns, fixed number of columns. Column 1, column 2, and column 3. This is the structured data. So table was bounded to the schema. And semi-structure means it's a schema-free table, or schema-free it is. We can store the data here irrespective of the schema. So JSON files, we are going to see how we can have a semi-structured data, how we can handle it. As a data engineer, we should know about how we can read the data from the JSON files. We have a unstructured data also. Unstructured data means plain text. Plain text is a unstructured data. Log details is a unstructured data. Your audio, video, unstructured data. Images, unstructured data. So we have a varieties of the data as part of your big data. And velocity, how fast you are going to process it, or how fast the data getting generated. So that is a velocity. So these 3 V's are there as part of your big data. Now, if I'm having a data here, if I wanted to process this data, how exactly we are going to process? I wanted to talk about here with the Hadoop approach. So since your traditional systems were not capable enough to process the data with SSIS or with data stage or with Informatica, whatever it is, those are all traditional systems. So to provide the solution, we got Hadoop into the market. So Hadoop also is going to do the same thing. What it is going to do is it is going to do the ETL processing only. Hadoop also does ETL processing. I have a structured data, I have a semi-structured data, and I have a unstructured data. So 3 varieties of this data is there in the system. All the systems, I just wanted to say data sources. All the systems, I wanted to say as a data sources. Now I need to read the data from here. In order to read the data, we need to extract from here. So by using Hadoop, we are going to write MapReduce programmings. It's 100% coding. And that too, you have to write that time, you have to write Java only. So 100% coding, and you have to extract the data from here and apply the transformations based on your business requirement, and then load the data into the HDFS. So from here, cluster is started. So cluster means collection of systems. You're going to have a collection of systems together is going to work. You're going to have a master node, something like this. All are going to work parallelly. If I have some work, if I wanted to make it done, if one person does this work, it takes some time. If the same work is going to done by multiple persons, then automatically time is going to reduce. The time is going to reduce when there is a multiple persons. So that is what it is happened here. So it's a distributed framework in order to process the data. And even in order to store the data into the target, we have a distributed storage. The distributed storage is HDFS. That is Hadoop distributed file system. It's not a normal file system. They introduced Hadoop distributed file system to distribute the data. If I have a 1 GB data in the source, this 1 GB is going to have a multiple blocks, and blocks are going to be distributed across the different nodes. So one block may be here, another block may be here, here, and so on. So this entire processing is going to be distributed processing. This entire processing was distributed processing. The only problem here is it's 100% coding. So this was a very, very big problem for ETL developers. If you take me, I work with SSIS and Informatica. So as I was ETL developer, I was not able to adapt this Hadoop is because it is 100% coding. It's very difficult for ETL developers to understand the code. That is one problem. And other problem is like other side, the persons who knows Java, these people also can do it. They can basically, these people more adopted this technology, but unfortunately they are not much more aware of ETL processing. Java developers can understand the Java code, but they cannot understand the ETL approaches. So only the persons who are having ETL experience, they can understand the ETL terminologies, how we can handle historical data, or how we can do the incremental loading. So this kind of problems faced, but still Hadoop was succeeded very huge, is because when there is a massive volume of data to process it, you have to go with the Hadoop only. So later there are many ecosystems came on top of the Hadoop to reduce the burden for the coding side. But still there are problems. So two problems, the major problems is, one is it's a disk-based processing. It's a disk-based processing. So every transformation, it is going to store the data in the disk, and then it is going to give it to another stage. So that is one of the big problem here. Another is you have to write huge lines of the code. Use lines of the code, you have to do it. These two are the major problems. To provide the solution for these two problems, so some people started providing solution for these two major problems. Instead of doing the processing in the disk, why don't we do the process in the RAM? If we process the data within the RAM, then the processing will be faster. So Spark came into the picture. The Spark is providing our alternative solution for these big problems by Hadoop. And it is 100 times faster than your Hadoop, because it is doing the processing within the RAM. There are many questions are there. I'll talk about it at the time of PySpark. At the time of Databricks, we're going to talk more in detail about what happened at the time of Spark introduced. And here also we have a few things, few problems are there. That is like, of course, it is 100% coding. That is fine. We don't have a problem with that, but the lines of the code is reduced. Lines of code is reduced. And they started using Python also. They have given a feasibility to write a Python scalar or and so on. So if the person is much more interested to write a code with the Python, then they can go with that. And Scala also came. The Spark was designed with the help of Scala. It's a native language of the Spark. Okay, so once this has happened, this is completely, they don't have a UI. So what happened is the UI also is started. So I'll give little more details at the time of Databricks. This is not the right time. So later Spark, or right after immediate of Spark, Databricks started. So Databricks are the founders of the Spark is the Databricks owners. They started a company called Databricks, and they have given a user interface to the people. And parallelly, what happened is, parallelly, there are many people started providing a solution from the different places. Like from Microsoft also, they started providing a solution for your big data. So that is with the next generation services, or we can say them cloud services. From Azure, they are providing a services to provide the solution for your big data. From AWS also, they are trying to provide a solution for big data. And GCP also started providing a solutions for the big data. But out of all these things, why Azure is much more famous for data? Because they concentrated more on the data processing. So these people are not concentrated more on data processing. So Azure is more concentrated on data side, and these people are more on infrastructure side. And GCP also the more or less same. We don't have much services in this place to provide the solution for your big data. And Microsoft came with a tool called ADF, Azure Data Factory. So Azure Data Factory is a completely code-free ETL tool or code-free ELT tool. Without writing a code, we can provide a solution for your big data. With Hadoop, you have to write 100% coding. With Spark, you have to write 100% coding. But if you go with the data factory, we can provide a solution without writing the code. So that kind of changes happen here. So to provide a solution, we have a Azure services, we have a GCP services, and we have a AWS services. Out of all the services, you can check anywhere, Azure services are much more famous for data processing. They introduced many services. So as a data engineer, what you're going to do is two primary responsibilities we are going to have it. There are two primary responsibilities. One is data ingestion, and other is data transformation. These two are the primary responsibilities of data engineers. Wherever you are going to do it, that may be Hadoop, that may be Spark, that may be Databricks, or that may be AWS, or anywhere. Wherever you are going to provide a solution for your big data, the primary responsibilities of data engineers are data ingestion and data transformation. Now, how we are going to do, since we are going to talk or we are going to learn about Azure data engineering positions or Azure data engineering, how Azure services are going to provide the solution for the big data, I just wanted to walk you through here. So just observe, same I have a same data sources. The way you're having Hadoop for Hadoop, the way you're having a sources for Hadoop. In the same way, from Microsoft also, for Microsoft services also, we are going to have a similar kind of services or similar kind of data sources. If I'm having a structured data, I can read the data from structured data sources. Like I have an Oracle database. I'm having experience on how we can read from Oracle systems. If you have a data in SQL Server, then you can read the data from SQL Server. Or if you're having a data from MySQL, you can read data from MySQL. These are all structured data systems. All RDBMS tools are going to have a structured data. So by using Azure Data Factory, as I said, from Microsoft, we are having a Azure Data Factory. It's a primary service from the Microsoft to provide a solution for your big data. So by using Azure Data Factory, I can read the data from the varieties of the platforms if there is a structured data. And if I'm having a semi-structured data also, I can read like JSON files or XML files. So these systems or this kind of file systems, we can say semi-structured data. They are schema-free tables or schema-free data it is. So when you go here, we need to have a fixed number of columns. Here, varying number of columns, you're going to have it. So at the time of practice, at the time of data factory, we are going to see how JSON files are going to be there. At the time of Databricks, how we can read the data from the JSON files, we're going to see. And we're also going to have a unstructured data. So in order to provide the insights for on top of unstructured data, you have to transform this unstructured data to structured data. How we are going to do it? By doing, basically, I recommended to do it by writing a notebooks in the Databricks. In the Databricks, we can handle by handling this unstructured data to structured data to get the insights on top of the data. So how we can process this unstructured data with Databricks, we're going to see. So as a data engineer, basically you're going to extract the data. So from varieties of the business systems, I'm taking the data. The process of taking data from these systems, we can call it as a extraction. Right after extraction, I'm just feeding the data directly into the Azure Data Lake Storage into, and ADF is data processing service, and ADB is a data processing services. Data processing services. And ADLS, SQL Server. Something like this, where we can say them as data storage. Data storage services. So your ADLS Gen 2 is specifically designed for storing your big data, which is specifically designed to process the big data. So this is equivalent to your HDFS, Hadoop Distributed File System. Okay, so we are going to have the data is going to be distributed across the different nodes. We are going to spend some time with the Azure Data Lake Storage Gen 2 throughout our sessions, how we can handle it. But if we observe clearly here, the transformation is missing here. We are not doing the transformation in the first stage. The first stage is data ingestion stage. In the data ingestion, we are not doing a transformation because this is not a ETL processing. This is a ELT processing. Your Informatica data stage, SSIS, does only ETL processing. While data is moving, it is going to transform. But here we are landing the data into the ADLS Gen 2. So what are the reasons to land the data into the ADLS Gen 2? We are going to talk more in detail about it. And once the data is landed in the ADLS Gen 2 from the varieties of the systems, then I need to do the second stage of work. The second stage of work is transformation. Here I just gave only one stage I have given, but basically there is a medallion architecture we are going to follow. So what is a medallion architecture? How we can handle it? We'll see that. So in the second stage, we are going to take the data from the Azure Data Lake Storage Gen 2, and we are going to apply a transformation here. Transformations With ADF, I can do it. But 90% of the market is not adopted ADF to do the transformation. 90% of the market is adopted ADB. So because of that reason, if you go for data engineering interviews, they're going to ask you, do you have an experience with the PySpark? Or do you have an experience with the Databricks? They will ask is because of this. In my experience, I used only Databricks to transform the data. We can do the transformation with ADF also. So this is not matured for transformation yet. So we need to wait. So the 10% I kept is because if there is any people, Microsoft, if they have given some opportunity or with less price, for many reasons, they may be tempted to use the ADF to transform the data. So this one, everyone can do it by doing a ADF. But I feel doing a transformation with ADB is much more easier than your ADF. You need to write only coding. In order to do the transformation with the ADB, you have to write only coding. But that coding is easier. I'm going to make you much more perfect to write a code to transform the data as per the business requirement. So here we are going to see the two things as part of this. One is RDD and other is a data frame. So in this also, market is much more interested with the data frame. I'll just give, in some situations, I recommend you to go with RDD also. I came across some situations to use the RDD as part of the data frame. So we are going to do the data transformation with only Databricks in many projects. But as part of our regular sessions, we are going to cover even this also to transform the data as per the business requirement without writing the code. So because of that reason, Microsoft is saying the ADF is a code-free ETL tool. It is a code-free ETL or ELT. We don't need to write a code, but maybe slowly they're going to make it much more stabilized. So I'll give how exactly this is going to work at the time of Databricks. I'm going to talk more in detail about it. And the target for this also, the target for the second stage is also is Azure Data Lake Storage Gen 2. You're going to store the data into Azure Data Lake Storage Gen 2 after completion of your transformation. So basically, you're going to have a multiple layers here. Medallion architecture, we are going to handle it here. We are going to have a bronze layer, silver layer, and gold layer. So we have a different kind of layers. This is bronze, silver, and gold. We'll talk about all those things at the time of project. We are going to see that. This project I'm going to spend about 20 days. So I'm going to make you to do it. If you can do that project, I'm sure you can survive any kind of project in the Azure data engineering. Okay. And once you're done your ingestion and once you're done your data transformation, then what you have to do? You have to automate this entire process. You have to automate it. That orchestration we are going to do with the ADF. Data ingestion is much more recommended for ADF, and data orchestration also we can use with the ADF, recommended to use, and ADB is recommended for data transformation. So once you have done all these things, once you transformed, once you automated, then the data is going to be ready for downstream systems. The downstream systems are going to have a reporting team. So that means you are responsible to give the data to reporting systems. or reporting teams. So how they're going to build the report, it's their headache. Our job is we have to give the cleansed data to them. So if there is a SCD type 1 and type 2 implementation, 100% it is required on type 2 and type 2 implementations. So these people are not going to be aware of it. As a data engineer, you are going to do it. And incremental loading, full loading is responsible by data engineers, not by the reporting team. So reporting team is ready to use your data to visualize the data as per the business requirement. So you are going to give a support to them if they're required. Otherwise, we don't need to give them. They're going to be aware of it. And we're also going to give the data to the data scientists also. Especially they used to take the data from the silver layer. So from gold, reporting team will take, and from silver, a data scientist teams is going to take it. So it's all depends on the requirement. They may take the data from the silver layer or gold layer. And these people also takes the data from the gold layer. So that means you are providing a data to the downstream systems. As a data engineer, you are responsible to do it. I hope everyone is clear. So what we are going to do is we are going to give the data to the downstream systems for doing the analysis. So when you start doing a working, how exactly you are going to start it? On what basis we are going to start? What kind of data is there? How we can do the data discovery? Data discovery is important. And control table entries, development, testing, unit testing, orchestration, and monitoring. These are all the responsibilities of data engineers. Okay, so how exactly we are going to start if we get a new development activities that we are going to see. We are going to talk about it. So to whom it is going to be suitable, I just wanted to give some details about it. It is common for everyone. The folks who are trying to get a job with a few years gap. If you have a gap, then you're 100% suitable for data engineering training. This is Azure data engineering. So you can take this training to get the job, to settle. And the folks who are trying to migrate your skill set. So just let's imagine I'm just working on Hadoop. I wanted to migrate from Hadoop to Azure engineering services. Then this is the right place. Or this course is right course to migrate from your old skill set to next generation skill set. So if you want to migrate your skill set, then you can go for that. And it is even suitable for freshers also because it was introduced in the academics, data science, data engineering. All these are introduced. So you can also go with that. There are many companies are recruiting even freshers. And the folks who are having non-IT experience. Let's say I'm working on Excel. I wanted to get more salary. I wanted to migrate my skill set. Then take a training on Azure data engineering. You can survive it. If you can complete the training with me, I'm sure you can easily survive without problem. And then what we are going to provide and what are the prerequisites? In terms of technologies, I'm saying prerequisites, but to start this training, a different kind of prerequisites we're having. We are going to talk about it. When you're going to work as a data engineer, keep in mind 100% you required these two prerequisites, SQL and Python. PySpark. PySpark means Python plus Spark. Spark is an engine. Spark is a framework. And we are going to write the code in the style of Python. So Python is very, very important. Where it is important? In the Databricks. In the Azure Databricks, it is important. If you know Databricks, we can work with the Azure. We can work with the GCP. And even we can work with the Amazon. Because for all these people, Databricks is common. If you know at one place, you can work in this place, or you can work in this place, or even you can work in this place. Because Databricks is not part of this. Databricks is associated with this cloud vendors. So working with Databricks in one cloud platform is very much similar with other cloud platform also, with minor changes. And where we can use this SQL is structured querying language. In the ADF, it is important. If my data source is the Oracle, if I'm trying to read the data from Oracle with ADF, then definitely 100% everyone is going to write a SQL code. That's the best practice. So ADF also is going to utilize the SQL code. And ADB, we are having Spark SQL. We are going to have a delta tables in this place. Tables are there here. So in that case also, we are going to use the SQL. And it's 100% is required in order to do the transformation. You have to write a PySpark code. To write a PySpark code, you required Python. So Python extensively used in the Databricks. These two things I'll take care about it. You don't need to worry. You don't need to take a training from anywhere. So I'll take care about it. This is out of the boundary, but I'm going to take care about for you. And then the next important thing is what we are going to provide here. What we are providing. I just wanted to give a list here. What we are going to provide from the Rudrasoft. SQL basics and Python basics will be taken care by ourselves. So you don't need to take a training from anywhere. So we are going to concentrate what we required, which is specific to the data processing. And whatever I'm showing in the screen, all those materials are going to be provided in the form of PDF. So you have to do the practice with ADF and ADB. With ADF and ADB, you have to do the practice. For practice, I'm going to provide a sample data. And weekly, we are going to have a 6 days from Monday to Saturday. From Monday to Saturday, we are going to have it.